Hello everyone, welcome back to the channel. Hope you're all doing well. Today's video we're in the CNC room where I made a new spoil board for the CNC with a couple of new options for work holding like T-track and bench dogs. Let me show you how I made it. In Fusion 360 I designed the spoil boards. This is the base frame of the CNC machine. It's made out of 100mm by 50mm rectangular tubing. It's quite strong and sturdy. On top of the base frame I added 4 board mounts and then added the CNC base made out of 16mm MDF. This gave me a flat surface to work on for mounting the spoil boards. The spoil boards are designed to be exactly the same dimensions and exactly the same hole pattern for easy replacement and easy machining. The machining will be a two-sided operation, one for the top face and one for the bottom face. With the boards being exactly the same dimension, I can use the same toolpath and operations to replicate across the 6 boards. In the manufacturing space, I was able to create the toolpaths. As it was a two-sided operation, I made sure to use the same reference point in my XY position for the top and the bottom. By using the same X0, Y0 position in the machine, it was easy just to flip the board over and having the exact same 0 on the machine. By referencing the same X0, Y0 position, I was able to place all 6 boards in exactly the same position for both sides machining. The footprint of my machine is on the Y-axis 1500mm and on the X-axis 1000mm and on the Z-height 100mm. The cut envelope, which is the size of the spoil board, is 1200mm by 820. Before I could start machining and making any cuts, I had to square out the machine. The X Gantry and the Y-axis was not quite square and I had to correct that. We'll be using some mathematics to determine by how much in which direction. I jogged the machine to a point on the spoil board, marked that as my X0, Y0, jogged the machine in a Y direction, 400mm, and in the X direction, 300mm. And according to math and Pythagoras, the distance between the Y point and the X point should then be 500. In my case, the distance between the Y and the X was slightly over 500, I think it's 502mm, meaning the X gantry is slightly out of square from the Y, and that needed some adjustment. And in order to make that adjustment, all we needed to do is turn the ball screw a couple of degrees, 1 or 2 degrees at a time, run the test again, and make sure the measurement is exactly 500 between the Y and the X. I've already done that test. As you can see, my scribe lines, and the distance now between the Y and the X is exactly 500, meaning we've got a square triangle and the X is square to the Y. Now we can start placing the boards and run repetitive cuts. And in my case, guys, it was quite easy to make that adjustment. All I needed to do is turn the ball screw either a couple of degrees to the left or to the right. In my case, it needed to go to the right, bring the gantry back. And the second step then was to measure the distance between the limit sensor and the machine plate on both sides. All I needed to do is loosen the bolts and either push the limit sensor forward or backwards, tighten it up again and make sure that that distance is exactly the same. And that will keep the machine in square every time I home it and every time I reference it. I placed the auxiliary fence in the Y direction and auxiliary fence in the X direction, and that gave me an exact spot where I can place the bit on X0, Y0 every time I place a board onto the machine. So with the machine now homed and referenced to the X0, Y0 position, the file is loaded in Mach 4, and we can now set the 0 position by zeroing the Z-axis on top of the workpiece. Once it's zeroed, we can start with our first operation. I'll be using an 8mm upcut bit, and it should leave a smooth surface on the MDF. The first operation is for the dog holes. I'm using a 2D pocket operation here with a 4mm step down. Unfortunately, my dust collector was out of order and I had to follow along with my vacuum cleaner. With the first operation now complete, the upcut bit really left a clean edge on the MDF. The slotted holes came out perfectly for mounting. And the bench dogs fitted exactly into the holes as they should. It's now time to flip it over and do the back side, where we'll be doing some boring and some pockets for the T-nuts. So I'll be doing that on all 6 boards now. Here you can see the pockets being machined, and later you'll see the boring operation. I realized only after the machinist started cutting that I did not add work holding to the back of the workpiece. Luckily this did not interfere with the machining. While the CNC was running in the background, I received a delivery with some tools I ordered online. The center punch I always needed, and just look at this tiny little hand plane, block plane. It might look like a toy, but it's extremely sharp. I really like it. I also received the palm router jig that you attach to the palm router for cutting circles and making straight potatoes using your router bit. The jig is made from anodized aluminium. It feels like good quality and very clear markings. Okay, back to the project. I designed the spoilboards to make use of a T-track with T-bolt option for sliding in and out between the 2 boards. However, I'm not making use of T-track in this solution yet. I opted for rabbets on the sides of the spoilboards, creating a T-track for the T-bolt to slide in and out, and using an 8mm spacer to keep the exact same spacing between the spoilboards. The rabbets are only 2mm deep, leaving enough wood on the board to prevent tear out. On the router table I set the fence to the correct position and the router bit to the correct cutting height. The first boards went well, and then this happened. Have a look at the router bit. Here's a slow motion view of what happened. Somehow the router bit came loose out of the collet and made its way up, cutting straight through the board. With this board I just trimmed off the back piece and used it as the last board. After tightening the bit and the collet in the router, I set the correct bit height again and continued with the operation. But now with all the boards completed, I'm quite happy with the way it turned out. All the edges are nice and clean and smooth. This is the top area. We've got 19mm dog holes to accept the bench dogs. This will allow for squaring up workpieces on the spoilboard. We've got slotted grooves for mounting the spoilboard onto the base of the CNC, and then we also have threaded inserts at the bottom, which will allow us to screw hold downs from the top and secure the workpiece on the spoilboard. Alright guys, to make it easier for installing and mounting the new spoilboards, I've removed the baseboard from the CNC to get access to the bottom of the board. At the bottom I also added some T-nuts for the bolts to go into the mounting slots and hold the board down onto the baseboard. That's the easier way to assemble, and I've also making sure that I'm using my spacer to keep the exact spacing and the exact distance, referencing the Y-axis fence, making sure everything is still square once it's mounted. The slotted mounting holes are recessed, allowing the bolt head to be below the surface by as much as 4 mm, giving me sufficient space and material to resurface. And to ensure I'm still 100% square, referencing the Y fence, I'm also using my framing square to check the alignment, making sure that between the dog holes I still have a 90-degree angle. So that's fine, it still lines up with the second board. For the CNC spoilboard I will not be using these bench dogs, I will be making my own, and for work holding, 3D printed toe clamps to be used on the T-track and the threaded nuts. So you can now see the pattern of how we're going. We're going to add the rest of the spoilboards, checking squareness on each and every one. And once it's done, we'll put it back on the CNC. I'm using my drill guide and a 7mm drill bit to drill straight through where the positions for the T-nuts are. This way the bolt of the work holding clamp can thread straight through the spoilboard. And testing the spacing for the T-bolt, the bolt glides into the groove with no binding. The side of the spoilboard will be kept open for sliding T-bolts in and out. So with all the spoilboards attached to the baseboard, I remounted it on the subframe of the CNC. The M8 bolts are easily reachable if I need to replace any of the boards. The bench dogs are also perfectly aligned, holding workpieces square and giving me a reference point for repeatable cuts. To finish this build I need to surface the spoilboard, making sure the spoilboard and the machine is completely parallel. I 3D printed some bench dogs and some hold down clamps. In the clamps I'm using M8 bolts that can screw straight into the threaded nuts. The hold down clamps also accept a standard M8 T-bolt with a nut. These can slot into the T-track and set as required. So guys, for the design and making of my CNC spoilboard, I really want to give credit and thanks to Corbin Dunn and Jay Bates. They both have excellent videos on their YouTube channels for designing and making spoilboard on their CNCs. I'll link to their videos down below. You should go and give that a watch. Thank you.